So these are the notes for 2.3, which is about linear functions and slopes. We kind of looked at some different kinds of functions and graphs in 2.2. Now we're going to be looking in particular at lines. So let's talk about slope. A slope is something that passes through 2 points, x1, y1, and x2, y2. And there's a number of different ways you can find it. You can look at change in y over change in x, which is also called rise, the vertical change, over run, a horizontal change. Or algebraically, you can find it by doing y2 minus y1 over x2 minus x1, as long as x2 minus x1 does not equal 0. Okay? And so what we're going to do in our first example here is we're just going to find some different slopes. So that's just to find the slopes of the line passing through each pair of points. We use the letter M to abbreviate slope, so M for slope. We're going to do y2, which is 4, minus y1, which is negative 1, over x2, which is negative 2, minus x1, which is negative 3. You might notice on both top and bottom I have minus a negative. Remember that minus a negative really means plus. And so on top we have 4 plus 1, which is 5. On bottom we have negative 2 plus 3, which is 1. 5 over 1 is 5. All right, so let's look at our next one. We got negative 3, 4, and 2, negative 2. So we do y2, which is negative 2, minus y1, which is 4, over x2, which is 2, minus x1, which is negative 3. On the bottom here, we do have minus a negative, so that's really a plus. So negative 2 minus 4 is negative 6, over 2 plus 3 is 5. Negative 6 over 5 does not simplify, so that's as good as we can get. So there you go. It's pretty easy to calculate slope, not too bad. Now, there are 4 different types of slope that we can see. Positive slope, like what we got here when we got 5, it's a positive slope. Negative slope, which is like what we got here, negative 6 over 5. Zero slope, which is where we have 0 on top, but we have a number on bottom that's not 0. And then undefined slope, which is where we have a number that's not 0 on top, and we have 0 on bottom. Now, a positive slope means that when we graph it, as we go to the right, the graph is going to go up. A negative slope means as we go to the right, the graph is going to go down. A zero slope means we're just going to go horizontally, and we're going to have the same y value throughout. And an undefined slope means we're going to go vertically, being up and down, the same x value all the way through. Now, once you know a point on a graph and a slope, you can actually write an equation for that graph. So the point slope form of a non-vertical line with slope m going through the point x1, y1 is given as y minus y1 equals m times x minus x1. Okay? In this equation, this y1 and this x1 refer to your point here. And m is your slope. This x and this y are just variables. You just leave them alone. You don't do anything to them. All you have to fill in is y1, x1, and the slope. Those are the only 3 things you fill in. So here, let's look at an example. It asks us to write an equation in point slope form for the line that has a slope of 4 going through the point negative 1, 3, and then solve the equation for y. So if we fill in, we have y minus y1, which is the y of our point, in this case 3, equals m, which is our slope is 4, times x minus the x1, which is x of our point, negative 1. Now here this is minus a negative, so it's really a plus. So this equation is y minus 3 equals 4 times x plus 1. So that's the point slope form. Then they asked us to solve the equation for y. So I got to get y by itself. The first thing we do is we get rid of the grouping symbol, we get rid of the parentheses by distributing the 4 in. So we'll have y minus 3 equals 4 times x is 4x. 4 times 1 is 4. And then we can take this 3 and we can add it across, and we get y equals 4x plus 7. This right here is another form of the line, which is called the slope-intercept form. And we'll talk a little bit more about that in just a few minutes. And I just wrote the word slope twice because I'm being silly. Slope-intercept form. So this right here is point slope, and this is slope-intercept. Okay. Let's look at a slightly more complicated example of this. Example 3 asks us to write an equation in point slope form for the line that passes through the points 4, negative 3, and negative 2, 6, and then solve the equation for y. Well, this time they didn't give us the slope, so we're going to have to find it. And we can do that with these 2 points. So we're going to do y2, which is 6, minus y1, which is negative 3, over x2, which is negative 2, minus x1, which is 4. On top, we do have minus a negative, so that's really a plus. 6 plus 3 is 9. On bottom, negative 2 minus 4 is negative 6. This does simplify because they're both divisible by 3. So this can become 3 over negative 2. So there's our slope. Now that we have a slope and we have points, we can actually write our equation in point slope form. Now, you can use either point to do this. So you can either write y plus 3 equals 3 over negative 2 times x minus 4, which is if you're using this point. Or you can use this point and say y minus 6 equals 3 over negative 2 times x plus 2. Either one of those is okay. And I'm going to prove that either one is okay because when we solve for y, we're going to get the exact same thing, no matter which one we did. So I'm going to solve this one for y first. Y plus 3 equals negative 3 halves times x is negative 3 halves x. Negative 3 halves times negative 4. Well, 3 times negative 4 is negative 12. Divided by negative 2 gives us a positive 6. And then I can subtract the 3 across, and I get y equals negative 3 halves x plus 3. But what if instead of using this one, what if I'd used this one? Well, it works the same way. We have y minus 6 equals, we distribute this in, so negative 3 halves times x gives us negative 3 halves x. Negative 3 halves times 2, well, 3 times 2 is 6. 6 divided by negative 2 is a negative 3. And then we can take the 6 and we can add it over. And so we get y equals negative 3 halves x plus 3. Notice we got the same exact thing. Didn't matter which version we used. Okay? So on your test, you don't have to write both of these. You just write one of them, and then you solve for y. Okay? But you can do either one. It's up to you which one you want to do. All right. So the next thing we're going to talk about is slope-intercept form, which I mentioned earlier. So if you use your point when you were doing point slope form, if instead of picking a random point, if instead you pick the y-intercept, which is 0, comma b, this is what your equation becomes. You plug in the point, so you plug in 0 for x and b for y. So you have y minus b equals m times x minus 0. X minus 0 is just x. So here on the right-hand side, you just have mx. And then you can move the b across, and so you end up with y equals mx plus b. And so this form is called the slope-intercept form. In it, m represents your slope, and b represents your y-intercept. Now, why would we ever want this form? Well, this form is actually easier to graph than the one that we had up here. This one, because you have the slope and the y-intercept, you can actually graph it really simply. And so that's what we're going to do next. Here's our steps for graphing in slope-intercept form. Step 1, plot the y-intercept, 0, b. Step 2, obtain more points using the slope. Remember that slope is a fraction, and you can do rise over run. So the top of the fraction represents how far you go in the y direction, and the bottom of the fraction tells you how far you go in the x direction. And then once you have several points, you can use a straight edge to draw a line, connecting all the points together, and then you draw arrowheads at the end to show that it continues indefinitely. So let's look at some examples of this. I'm going to start, I'm going to draw in my axis lines. So my x-axis and my y-axis. So here, if I look at this equation, f of x equals negative 3/2 x plus 2. My slope is negative 3/2, which you can write it either way, negative 3 over 2 or 3 over negative 2. It doesn't really matter. My b is this number here at the end, which is the 2. B tells me my y-intercept, so I'm going to plot that point first. There's my y-intercept at 2. And then I'm going to use my slope to get other points. So if I write my slope like this, it means I go down 3 and to the right 2. So I go down 1, 2, 3, and I go right 1, 2. I go down 1, 2, 3, and I go to the right 1, 2. Okay. If I look at my slope this way, this top number tells me I go up 3, and the bottom number tells me I go to the left 2. So I go up 1, 2, 3, and to the left 1, 2. Okay. And once you have a couple of points, you can connect them together using a straight edge. And then you can put arrowheads at the end to indicate that it does continue going indefinitely in both directions. And so there is our linear function. Okay. All right. Next thing, horizontal lines. If you have a horizontal line, then its slope is 0, which means m equals 0. When you plug that 0 in for m, 0 times x becomes 0. 0 plus b just becomes b, and so you just get an equation, y equals b. So anytime you see something that's just y equals a number, you're getting a horizontal line. And so let's look at an example of that. So this is asking us to graph y equals negative 4 in the coordinate system. So since it's just y equals a number, it's a horizontal line. So I'm going to go to where y is negative 4, which is down here, and I'm going to draw a horizontal line. And I'll put arrows on it to indicate that it does continue going in both directions. So that is my graph. Pretty straightforward for horizontal lines. Next thing is vertical lines. Vertical lines have an undefined slope, so that means we can't actually use our point slope or slope-intercept forms. They just don't work. Instead, for vertical lines, our equations are just x equals a, or x equals some number. And so that number just tells you where your vertical line is. So here in example 6, we're going to graph the linear equation x equals 2. So I'm going to go to where x is 2, 1, 2, and I'm going to graph a vertical line going up and down. And I'm sorry that's not a perfect line, but I'll have to do. So there is our vertical line for x equals 2. Now, any line, vertical or not vertical, can be written in what's called the general form, of a linear equation, which is ax plus by plus c equals 0. A, b, and c are all real numbers, and a and b can't both be 0. Either a is 0 or b is 0. It's one or the other. So when we have an equation like x equals 2, we could express it as x minus 2 equals 0, meaning we can move the 2 over like this. And that means we could actually rewrite it as 1x plus 0y minus 2 equals 0. And it would fit that general form, ax plus by plus c equals 0. Now, why would we ever use the general form? Well, in the general form, it's really easy to find your x and y intercepts, and then you can actually just plot from there, connecting them together. You could also take that general form and solve for y, and change it back into slope-intercept form, and it would be fine to graph too. So let's look at an example here. This one asks us to find x-intercept, y-intercept, and slope for the equation 3x plus 2y minus 4 equals 0. Well, remember, to find x-intercepts, you make the y equal 0. So we'd have 3x plus 2 times 0 minus 4 equals 0. We have 3x. 2 times 0 is 0. 0 minus 4 is negative 4. So we get 3x minus 4 equals 0. Add the 4 across. We have 3x equals 4. Divide by 3, we get x equals 4 over 3, 4 thirds. So our x-intercept would be 4 thirds, 0. For y-intercepts, remember that we make x equal 0. So we're going to plug 0 in for the x's. 3 times 0 plus 2 times y minus 4 equals 0. 3 times 0 is 0, so this just goes away. So we have 2y minus 4 equals 0. Add the 4 across. 2y equals 4. Divide both sides by 2, you get y equals 2. So my y-intercept is at 0, 2. And then the last thing we want to find is the slope. So to do that, we solve this equation for y. So I'm going to move the 3x and the 4 over. So I'll have 2y equals negative 3x plus 4. Then I'll divide everything by 2. And so I get y equals negative 3 halves x plus 2. Which of those numbers is my slope? It's the number multiplied by the x. So my slope is negative 3 halves. Now, again, it's harder to find slope here in this standard form. We had to solve for y. But x and y intercepts were actually both pretty easy to find. And that kind of leads into our next thing. If you're given an equation in standard form, all you got to do is find the x-intercept and y-intercept, and then you just plot them and connect them together, and it makes a line. It's really easy. And so that's what we're going to do in here in example 8, is we're going to draw a line from an equation that's in standard form. So this one asks us to graph using the intercepts. So the first thing we're going to do is find the x-intercept. We'll plug in 0 for the y. So 4x minus 3 times 0 minus 6 equals 0. That gives us 4x minus 6 equals 0. Add the 6 across. 4x equals 6. Divide both sides by 4. So x is 6 over 4, which simplifies to 3 over 2. So we have this point 3 over 2, 0. 3 over 2 is 1.5. So it means we're at 1.5, 0. So there's our x-intercept. All right, for y-intercept, we plug in 0 for the x. So we have 4 times 0 minus 3y minus 6 equals 0. 4 times 0, that's just going to go away. So we have minus 3y minus 6 equals 0. Add the 6 across. Negative 3y equals 6. And then divide both sides by negative 3. We get y equals negative 2. So 0, comma, negative 2 is our y-intercept. It would be down right there. Now that we have the two of those, we can connect them with a straight line. And we can put little arrowheads at the end to indicate that that line does continue in both directions. And so there is a graph of that linear function. So as you've seen, there's multiple different ways we can graph these lines. No one way works all the time. All right. Next thing is parallel lines. Parallel lines are lines that have the same slope but different y-intercepts. So if you say two lines are parallel, what you are saying is that they have the exact same slope. So example 9 here asks us to find an equation for a line that contains the point 2, negative 3, and is parallel to this line. So parallel means it has the same slope as this line. So I need to know what's the slope of this line. I do that by solving for y. If I take the 2x and move it over, I get negative 2x plus 6. What's the slope of that line? The slope is negative 2. So if I am parallel, then my parallel slope, these two little lines right here mean parallel. So my m is slope parallel, so my parallel slope is also negative 2, because parallel means the same slope. So then we're going to take the point they gave us and the slope that we have, and we're going to write our equation. Y plus 3 equals negative 2 times x minus 2. And so there's the equation of our line. Now they didn't ask us for any specific form, so we can actually just leave it here in point slope and not have to simplify it. Okay. All right, perpendicular lines. Perpendicular lines are lines that have opposite reciprocal slope. What that means is if you take the slope, you flip the numbers around the fraction, and then you change the sign. So if it's positive, you make it negative. If it's negative, you make it positive. So let's look at an example of that. So example 10 asks us to find an equation of a line that contains the point 1 comma negative 2 and is perpendicular to the line x plus 3y equals 6. So perpendicular means opposite reciprocal slope. So I need to find the slope of this line first. I'm going to move the x over and say 3y equals negative x plus 6. And then I'll divide everything by 3. And so I'll get y equals negative 1/3 x plus 2. So the slope here is the number next to x, so it's negative 1/3. Now I'd like to know what is the perpendicular slope. This is a little symbol for perpendicular. It's kind of a little line making a right angle. So we want to do opposite reciprocal. So opposite means I change the sign, so instead of negative, it's going to be positive. Reciprocal means I flip the numbers. I'm going to have 3 over 1, which is the same thing as 3. So there's my perpendicular slope. Here's the point I want to go through, so I'm going to have y plus 2 equals 3 times x minus 1. And I can leave it like that, although I'll have to probably rewrite it when I want to find my line to graph. Alright, so I'm going to graph these lines. I'm going to graph the original one they gave us here in black, and then I'll graph the perpendicular one in blue. So for this one, the y-intercept is 2. So up 1, 2, right there. My slope is negative 1/3, which means I go down 1 and to the right 3. So down 1, to the right 1, 2, 3. I could also put the negative on the bottom. If I did that, it would be up 1 and to the left 3. So up 1 and to the left 1, 2, 3. Once I have a couple points, then I can connect them together. And I can put lines here on these to show that they do continue forever in both directions. All right, for our perpendicular line, we're going to have to solve this equation for y. So we distribute the 3 in. 3 times x is 3x. 3 times -1 is -3. Subtract the 2 over. So you get y equals 3x minus 5. So that means my y-intercept is -5. 1, 2, 3, 4, 5, all the way down here. And my slope is 3, which is 3 over 1. So that means I'm going to go up 3 and to the right 1. So up 1, 2, 3, to the right 1. Up 1, 2, 3, to the right 1. Up 1, 2, 3, to the right 1. And then we can connect those together. Well, we can try to connect them together. Put arrows here at the ends. Now if you did it right, it should look like it's forming a right angle right there where the two lines cross. It should look like they're at a right angle. Okay. Alright. And that is it. So that's it for section 2.3. As always, if you have any questions, feel free to send me an email.